Ever wondered how the coding languages evolved over time? It all began in the 1940s and 1950s, an era dictated by machine languages and assembly languages. Imagine trying to communicate with a machine using a language only it could understand. Sounds challenging, doesn't it? Well, that was the reality of the early coders. In those days, coding was like trying to write an elaborate symphony but for machines. Every single instruction had to be meticulously hand-coded, a process that was not only laborious but also prone to errors. And debugging those errors? That was another Herculean task altogether. Programmers of that era were like pioneers on a digital frontier, wrestling with the rawest form of machine language. They had to navigate through the complex labyrinth of 1S and 0S, day in and day out. But these challenges didn't deter them. Instead, they stirred a desire for a more user-friendly system. The need for a more accessible language paved the way for the development of high-level languages. In the late 1950s, high-level languages started to emerge. This period of programming history was marked by a significant shift in the way humans communicated with machines. As we transitioned from assembly languages which were closely tied to the hardware they ran on, we found ourselves stepping into a new era of programming languages. One of the most influential players in this shift was Fortran, short for Formula Translation. Developed by IBM in the mid-1950s, Fortran is considered the first high-level language. It was designed to be easier to read and write than assembly language, and it was more portable, meaning it could be used across different hardware platforms. Before Fortran, programming was a laborious process. Coders had to write in machine code or assembly language, both of which were time-consuming and prone to errors. Imagine trying to write a novel using only a Morse code manual. That's what it was like to code in these early languages. But Fortran changed all that. It allowed programmers to write code in a language that was closer to English, making it more accessible to people without a background in computer science. It was a revolutionary step that transformed the world of programming. In addition to its readability, Fortran also introduced the concept of loops and conditionals. These are fundamental concepts in programming that we take for granted today, but at the time they were groundbreaking. Fortran's impact on the programming world cannot be overstated. It paved the way for the development of other high-level languages, and it proved that programming could be more than just a tedious chore. It could be a creative process, a way of solving problems, and making machines do incredible things. Fortran was just the beginning. The 1960s saw the birth of many new languages. This was a time of rapid innovation in the field of programming. As we moved into the next decade, we would see the emergence of languages like COBOL and ALGOL, which took the principles of Fortran and expanded upon them. But that's a story for another time. For now, let's celebrate Fortran and the dawn of high-level languages. The 1960s, a decade that saw the birth of many new languages. As the world was stepping into the decade of the 1960s, a whirlwind of innovation was stirring in the realm of programming. This period was marked by the development of key languages including ALGOL, COBOL, and BASIC, each designed to solve specific problems and contribute significantly to the evolution of coding. ALGOL, an abbreviation for algorithmic language, came into being in the early 1960s. It was developed by an international committee with a vision to create a universal language for algorithms. ALGOL was a pioneer in many ways, introducing concepts such as block structures and lexical scoping. Despite its lack of commercial success, ALGOL's influence was immense. It became a progenitor for many subsequent languages, including Pascal, C, and Java. Next, we step into the world of COBOL, or Common Business-Oriented Language. Born out of the need for a language that could handle business data processing tasks, COBOL was designed to be readable and maintainable. It was one of the earliest high-level programming languages and was widely adopted in business and government settings. Today, believe it or not, there's still a substantial amount of COBOL code in operation, particularly in legacy systems. Last but certainly not least, we have BASIC, an acronym for Beginner's All-Purpose Symbolic Instruction Code. Developed in the mid-1960s, BASIC was created with the intent to enable students to start programming quickly. It was designed to be simple and easy to learn. Despite its simplicity, BASIC had a profound impact. It was the first programming language for many coders and sparked a revolution in home computing in the 1970s and 80s. Each of these languages, ALGOL, COBOL, and BASIC, played a pivotal role in the story of programming. They were designed to tackle unique challenges, and in doing so, they pushed the boundaries of what was possible in coding. the 1960s set the stage for a new wave of programming languages. The 1970s brought us one of the most influential languages in history, C. Nestled in the heart of the decade, the language of C was born, a creation of Dennis Ritchie at Bell Labs. The language was sleek and powerful, a thoroughbred in the world of coding that bridged the gap between high-level languages and the machine language of hardware. C took the programming world by storm. It introduced a new way of thinking about code, with its focus on procedural programming and direct manipulation of system hardware. This offered programmers a level of control previously unseen, allowing them to squeeze every ounce of performance from their machines. The language was flexible, efficient, and portable, making it an ideal choice for a wide variety of applications, from operating systems to game development. But the 1970s didn't stop at C. This decade also saw the rise of a paradigm shift that would shape the future of programming: the advent of object-oriented programming, or OOP for short. Born from the minds of Ole Johan Dahl and Kristen Nygaard, Simula was the first language to introduce the concept of objects, classes, and inheritance, the fundamental pillars of OOP. This was a revolutionary approach that allowed programmers to model complex, real-world systems with unprecedented ease and accuracy. Following in Simula's footsteps, Smalltalk pushed the boundaries of OOP even further. Developed at the fabled Xerox PARC, Smalltalk was designed to be a fully object-oriented language, with every value being an object and every operation a message. This was a radical departure from traditional procedural languages and marked a significant milestone in the evolution of programming. The impact of C and the rise of object-oriented programming cannot be overstated. They laid the groundwork for many of the languages we use today, from C++ to Python, and revolutionized the way we think about and write code. The stage was set for a new generation of languages. The journey from assembly to Python was not a short one. It's been a trek across decades, filled with innovation and the constant drive to make programming more accessible and versatile. Let's take a moment to appreciate the modern languages that have become the backbone of today's digital world. Python, Java, and JavaScript. Each of these languages has left an indelible mark on the programming landscape and continues to shape it in profound ways. Python, with its emphasis on simplicity and readability, has become a favorite among beginners and seasoned programmers alike. Its versatility is remarkable. From web development and data analysis to artificial intelligence and machine learning, Python has found its place in virtually every corner of the tech industry. Then we have Java, a language that truly embodies the principle of write once, run anywhere. It's the language of choice for enterprise-level applications, and its robustness and scalability have made it a staple in large systems worldwide. And let's not forget JavaScript, the lingua franca of the web. It has evolved from a simple scripting language into a powerful tool for creating dynamic and interactive web applications. With the advent of Node.js, JavaScript has even broken free from the confines of the browser, proving its mettle in server-side programming. These modern languages, with their high-level abstractions and user-friendly syntax, have significantly lowered the barrier to entry for programming. They have empowered more people to create, innovate, and solve problems through code. Yet even as we marvel at the advancements we've made, we know that this journey is far from over. New languages continue to emerge, each promising to push the boundaries of what we can achieve with code. We're entering an era marked by languages like Rust and Go, which aim to combine the efficiency of low-level programming with the convenience of high-level languages. The focus is shifting towards more secure, reliable, and efficient code, and these languages are leading the charge. So, as we stand at the cusp of this exciting future, let's remember that every line of code we write is a step forward in this grand evolution. As we look to the future, one thing is clear: the evolution of coding languages is far from over.